Sorry, guys. It's hot in here, all right? It's hot. All right, what was I talking about? Oh, yeah, I've already given you the equations. If you have specific heat, use that. If you have whateverness, you can use it. All right, remember, M equals Q over CT. C equals Q over MT. Easy enough. If you're trying to find anything other than Q, Q is always going to be on top. I can explain how the changes in heat change the entropy of a system during an experiment. If something gets more hot, it's going to have more entropy. This is because heat specifically is how the particles are vibrating. Sorry. How the particles are vibrating. If there's more vibration, then there's more entropy. Simple. We have already finished this. That is amazing. Now then, we only need to do the first 3 learning targets of Unit 2. Yeah! How fun is that? Not fun. That's how fun it is. All right. I can identify the discoveries. She didn't even go over Niels Bohr. Hello? Guys. Oh my gosh. Okay. Whatever. So, J.J. Thomson, right? The only reason why I remember him is because in our notes, he came first. And the reason why that's important is because I know J.J. Thomson only discovered that atoms have charge. That's it. He only discovered atoms have charge. Only that. Ernest Rutherford, whatever his name is, he said, oh, hey, the atoms that have charge, they have protons and they have electrons. Protons are positive, electrons are negative. Now, John Dalton, he was the one who came up with all those dumb theories about yada, 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 right? He came up with all the 4, 6, whatever, 6, 7. I'm sorry. I'm getting a bit too carried away. Dalton was the one who said, okay, atoms of the same element are identical. I had to redo that part. If I weren't on ban, some bad stuff would be said, alright? Matter cannot be created or destroyed. Matter is made of atoms. Compounds are 2 or more different types of atoms. Remember, atoms of the same element atoms of the same element are identical. Now, remember, that is the part of his theory that is wrong. Matter cannot be created or destroyed. Matter is made of atoms, and compounds are made of 2 or more different types of atoms. That is what Dalton had said. All right, which is simple. So we can go ahead and check off that. I can identify the atomic models proposed by John Dalton, J.J. Thomson, Ernest Rutherford, and Niels Bohr. Holy aura. Okay, so she didn't teach us Niels Bohr. I'm assuming we're not going to be tested on him during the test. And if we are, y'all are going to hear me screaming at the front of the class, all right? Kidding. I wish I could, but I don't think she would kick me out of the class and I would probably get OC or something, bro. Anyways, John Dalton, his model of the atom didn't look too dissimilar to what we think it is. All he said were, it's like that. Different sizes, different colors, some were together, some were apart. Thomson, he said the same thing, yes, but he also said atoms have a charge, any kind of charge. Now, Rutherford said, yes, they have electrons which are negative. So imagine it adding, right? Dalton, different sizes, different colors, different shapes. Thomson, yes, they have charge. Rutherford, I add 2 onto that. They have electrons, which are negatively charged. They had protons, which I think what's his name also discovered. Okay. I can explain the experiments of John Dalton, J.J. Thomson, Ernest Rutherford, and Niels Bohr. Simple enough, right? Dalton, he didn't exactly have an experiment. Thomson, on the other hand, he did. I think he used that cathode ray. So remember that tube with the light beam in it? And if you put a magnet near it, it would go toward that light beam. That's what he said. Now, what that is showing is that atoms have charge and they move toward the positive. They move toward it. I think. Yeah, they move toward the positive. Now then, Ernest was the plum pudding dude. He was doing the plum pudding, right? He said, okay, why is it that when atoms are surrounded by protons that nothing happens? Or something like that. That is because atoms have charge, however, they actually have a lot of empty space. He showed that atoms have a lot of empty space in them. So even if, a bunch of atoms were to be inflicted on them, some wouldn't hit. Only denser atoms would be able to hit them. And that, my beautiful people, is all that she wrote. I'm sorry for the corny ending. But I've been at this for gosh knows how long, alright? I've been sitting on the speaker that I don't even know if you could hear it, but it's been creaking. I'm 175 pounds, by the way, so I'd hope it stays together. Or I think I'm 175. I think it was 174 last I checked. But that doesn't make a difference, right? Am I right? All right. So I'm just going to go ahead and... We're not going to call it there. Or we are going to call it there because that's basically the end of the study session. If you have any questions, please comment them down below. I'll be happy to answer your questions. I'm glad, not really glad. I'm happy I can spend this time with you to help you study. But, comment down the questions below. Maybe not for the rest of the video, but for some time, I'm just going to talk to you all about random things. That was my setup. Big salt rock I got. That's illegal. Don't worry about that. I have my water bottle over here. My setup. It's kind of just like the light. Put it up here. But yeah, I hope you all had a good time studying with me. I think that was at least 40 minutes worth of content. Sorry if it's long or something, but seriously, there was a lot of stuff to cover, and she doesn't teach us jack anything. Oh, one thing that y'all need to remember, and I'm so sorry for getting this wrong. Whenever we do, let's just say that was an atom, and this was its whateverness, right? I'm so sorry for getting this wrong, and I'm deathly sorry. I felt so bad during the test. Apparently, it's not these two. It's this one. You minus and subtract these two. This one on the bottom. All right? So if that comes up on the test, just remember, it's going to be that bottom one. And if it's not there, then you have to figure out the atomic number of it or the amount of protons. That's how you get that, and that's how you start with that. All right? So I will see y'all later. Peace out.